5, question 2, we have a spreadsheet that is in the Canvas file, and we want to isolate 1973 through 1980. We want to calculate the arithmetic average return for T-bills and the average inflation rate for the CPI. We want to do the standard deviation of Treasury bills and inflation over the period. We want to calculate the real return, blah, blah. What else? There's a question about the risk-free rate. We'll get to that. Okay, so we want to isolate 1973, and there are a lot of years here. This is kind of a standard thing where there's like a spreadsheet with a bunch of years of return. I'm going to delete all of these just so I don't have to mess with them and worry that I'm referencing the wrong thing. So for those, there were a couple questions in class about this. The way to delete stuff is to just highlight rows and then come out here and kind of right click and hit delete. And of course now it's not going to do it. Let's try it again. There we go. All right, 1973 starts right here. Let's delete that. And we want to go to 1980 according to the question. All right, let's look back at the question and see what we need to do. Arithmetic average return for T-bills and the average annual inflation rate. These are T-bills. This is the inflation rate via the consumer price index. All right, let's make that just a little bit bigger. And then the next question is, what is the standard deviation? We'll do that right now. There are a lot of different ways to do this, but STDEV will get you exactly where you need to go. Let's change that to percent and add a few decimal places. Okay. Just off the bat, during the period from 1973 to 1980, T-bills made 7.7% and the CPI was 9.28. What does that tell you? Well, it means if you put $100 in T-bills that you had 107 and change at the end of the year, but that you would need 109 to purchase the same amount of stuff. So what we're going to see when we do this part, the real return, is that the real return is going to be negative. So let's just do that. If you remember, the real return is 1 plus Treasury divided by 1 plus consumer price index minus 1. And I'm going to get rid of a few decimal places because that is a lot. Okay, so what do we see here? We see that the real return in 1973 is minus 1.3%, and that makes sense, right? The Treasury bill return was a little bit lower than the consumer price index. The only year that we have a positive is in 1976, when the U.S. Treasury bill is 5% and the CPI is 4.8%. So a useful way to kind of check yourself to make sure you're not doing something stupid. If the actual return is higher than inflation, then the real return should be positive. If the actual return is lower, then the real return should be negative. And you notice that we get minus 1.4 and the standard deviation is 1.25. And the last thing is, most people consider Treasury bills to be risk-free. What do these calculations tell us about the potential risks of Treasury bills? Well, if we go back here, the calculations say the Treasury bill is, or the T-bill is risk-free in the sense that if I give the government $100 in 1979, I'm probably going to get back, well, I'm almost certainly going to get back 110 and 56 cents. that is fine, but I've lost purchasing power. So it's risk-free in the sense that I'm not worried that they're going to default. I'm going to get the money back per the promise, but it's not risk-free in the sense that I'm going to be able to purchase the same amount of stuff. And so risk-free only implies that they will give you the money back. It does not imply that the money will actually be able to buy the same amount of stuff.